Hey guys, hoping all is well with everyone. So in this video this is gonna be my first unofficial video for my 6th grade Common Core curriculum walkthrough and lessons. So I will be getting up the first 3 lessons up very soon, but I wanted to start with this one. And basically, again, all this my goals with the videos for my Common Core curriculums, with whatever grade they are for, is to give you a step-by-step approach to the really core foundational topics that are explored in these workbooks and textbooks, and really help you to understand and be comfortable with all of the lessons that they do here, as well as all of the practice problems. So we're going to start lesson 1.4, which is all about understanding division with fractions. And the goal is, after this section, that you can use models and equations to represent fraction division. Now, in this Explorer, it says students are competing in a 4-kilometer relay race. There are 10 runners. So we have the starting line at 0 kilometers. Each runner runs 2/5 of a kilometer, and the finish line is at 4 kilometers. Now, what we can do here is I'm going to be very detailed about how I'm going to do part A here. So it says use the number line to represent the data for the race. I'm going to start things off pretty simple. I'm going to go ahead and label the 0 as the starting line. And then I'm going to label the 4 as the finish line. So I want you to imagine this number line as like the distance that each of these runners are traveling. Now, the next thing that I want to do, very importantly, is to divide each of these 1 kilometers into fifths, because this is going to allow me to represent each runner and the distance that they run in this 4-kilometer race. Now, these are not going to be exactly equivalent, but I'm going to do the best I can to make sure they're pretty equal to each other. So the goal is to separate, or to divide, each kilometer into fifths. Okay. Now the reason that I wanted to do that is now I'm going to use different colors to represent to you and show you the distance that they each travel. And again, they're all running the same distance, so that should tell us that after 10 runners we should reach 4 kilometers. Okay, I'm going to start off with this red here. So this, remember, the distance between each line is 1/5. So if they run 2/5, they're going to go 2 lines worth of distance. Okay, so that's the first runner that ran 2/5. The second runner ran 2/5 as well. So right now, after 2 runners, they've run 4/5 of a kilometer. Okay, let's keep going. So this next runner is going to run 2/5. So it's going to pass the one and go to the next one. Oops. There we go. We have green for the next one. They ran 2/5. Blue for the next one. Now this one's going to seem kind of longer than the other racers, but again, remember, all of these are equivalent. So after 5 racers, they have gone 2 kilometers. Okay, so we have a dark blue next. Then we have a kind of a purple slash kind of almost like a magenta, not really magenta, but like a dark purple. The rest of these colors aren't the prettiest. I'll choose this kind of sky blue next. And I'll go with this kind of gray. And then our last runner is going to run the last 2/5, being this. Oh, that is not a good color to use against this book paper. I'll use this pinkish color. There you go. And the last runner is going to run 2/5 as well. So again, I know all of these lines aren't perfectly kind of equivalent from each other, but it's just to show you that each runner ran 2/5 of the race, and since there were 10 runners, they ran a total of 4 kilometers. Now, what I'm going to do here is, in part B, it says use multiplication or division to describe your work on the number line. So what I did essentially in the number line was I took 2/5 and I multiplied it by 10 runners. Okay, so each runner ran 2/5 of a kilometer, and there's 10 runners. So we can go ahead and do the multiplication here. One thing I want you to kind of think about, though, is when we multiply fractions by whole numbers, we can represent a whole number as a fraction. The way that we can do that is just by imagining the denominator of that whole number by 1. And the reason that we can do that is because when we divide any number by 1, the value doesn't change. 10 divided by 1 is 1, 1,000 divided by 1 is 1, 5,625,346,123 divided by 1 is that number. But basically, the idea here is any number divided by 1 is going to remain the same. But we can do this to simplify our multiplication of the fractions. So when we multiply fractions, we just multiply the two numerators, and then we multiply the two denominators, and then we can simplify the following kind of division or fraction that we see. So 2 times 10 is going to be 20, and then 5 times 1 is 5. And then 20 divided by 5 is equal to 4, which was the length of that race. Okay, so that's going to be how we can use multiplication, even a little bit of division too, because we did 20 divided by 5. But I also want to show you the other aspect of division that we're going to kind of be focusing a lot on with this next section. So this is going to be kind of like an inside look part. So when we divide fractions, it can get very, very tedious and very daunting very quickly if we were to try to really divide fractions. Because if you imagine what a fraction is, it's part of a whole. It's a decimal that is less than 1 but greater than 0. So it's like you're doing long division with decimals, and that can be very long and tedious and not the funnest thing in the world. But we can use the sibling operation, because multiplication and division are like sibling operations. They're kind of opposites of each other, brother and sister, so to speak. So what we can do is, instead of dividing by fractions, we can multiply by what is known as their reciprocal. So I'm going to go ahead and show you what that is. So let's say if I wanted to figure out, well, it's a 4-kilometer race. Each runner is running 2/5 of that race, or that relay race. How many runners are there? Well, all I have to do to determine that is take 4 kilometers and divide that by the amount that each person runs, which is going to be 2/5. And this is where we start to look at what is known as the reciprocal. The reciprocal of a fraction is just the opposite, or the kind of a flip of what the fraction would be. So for example, if 2/5 did a backflip, it would be 5/2, so to speak. Well, if it did a backflip and it just landed, it would just be 2/5. But anyway, the reciprocal of a fraction is just the kind of the flip-flop of it. So for example, the reciprocal of 2/5 is 5/2. The reciprocal of 1/8 is 8. The reciprocal of 3/4 is 4/3. By definition, mathematically, it is what is known as the number you would multiply by a fraction to get 1. So it's basically just its opposite, or it's just its flip-flop fraction. Because you would multiply 2/5 times 5/2 would give you 10 over 10. So I'll show you. If you multiplied 2/5 by its reciprocal, you get 5 over 2. And then this would give you 10 over 10, giving you 1. Now, in this case, what I'm going to do to divide by fractions is multiply by the reciprocal fraction of 2/5. So what I'm going to do here is I'm going to take 4 and multiply it by 5 over 2. Okay? This is going to give me the fraction 20 over 2. And now we can just use division. 20 divided by 2 is equal to 10, which is the amount of runners that were in this race. So just like I said, as a little insider look of what we're going to be looking at in this next section. Okay, so again, there's kind of ways that we can look at expressions or solving equations and problems using both aspects of multiplication and division kind of hand in hand, so to speak. Okay. So it says focus on math practices. Model with math. Describe what a numbered line would look like if there were 10 runners, each running half a 5-kilometer race. So let's go ahead and do that. Let's go ahead and make a number line. So this time I'll make it a little bit, okay. So there's our, I'm going to go ahead and break this up into a 5-kilometer race. So this probably won't be perfect, but I'll do the best I can. It's about 1/5. It's about 2/5. 3/5. 4/5. Okay, so this is our 5-kilometer race. It starts at 0 and it goes to 5. Now, in this case, each runner is running half the race. So what I want to do here is I want to break up each interval. So this is the 1st kilometer, this is the 3rd, this is the 4th, and this is the 5th. What I want to do here is I want to break up each interval in half instead of fifths like I did the previous one, because each runner is running half a kilometer instead of 2/5. So I'm going to go ahead and cut this interval in half. I'm going to cut this interval in half, cut this interval in half, cut this interval in half, cut this interval in half. And again, the reason for this is it allows me to represent the runners running half a kilometer, and that will show me the distance that they would travel in the race, so to speak. Alright, so let's go ahead and use those colors again just to kind of show what we're looking at here. So they each run half a kilometer. So the first runner runs, they run half a kilometer. Second runner is going to run, they run half a kilometer. So it took 2 people to reach a 1 kilometer distance. Okay, so let's keep going. So it took 4 people to run 2 kilometers. And the way that we can think about that is kind of like if we multiply 4 runners times 1/2, we get 2 kilometers. So we're so far so good. Okay, the next runner runs half a kilometer. Next runner runs half a kilometer. So again, 6 times 1/2 is 3. Or 6 divided by 3 is 2. So we're still good there. We have another runner. The way that we can think about this is this is the 7th runner, so we have 1, 2, 3, 4, 5, 6, 7. 7 divided by 2, or 7 times 1/2, is 3.5. So we can think about this again as division, 7 divided by 2, or we can think about it as multiplication, 7 times 1/2. Okay, alright, so now we have our 8th runner. 8 divided by 2 is 4, 8 times 1/2 is 4. My pink here, our 9th runner, and last but not least, our 10th runner. And again, 10 divided by 2 is 5, 10 times 1/2 is 5. Alright, so this is kind of our introductory activity for our lesson 1-4, Understanding Division with Fractions. We talked a little bit about what we're going to be looking at in the insider look of multiplying by fractions by whole numbers, dividing whole numbers by fractions using that reciprocal. So these are the kind of topics that we're going to be looking at in our forward lessons. If you guys have any questions about this explored activity, please don't hesitate to ask me. I'd be more than happy to help you out. But I look forward to seeing you in the next video, where we'll be continuing on with lesson 1-4. Thank you guys so much for watching, and take good care.